Ciao friends, and welcome to a new video from SQL BI. This is the first of a series of videos where I want to introduce the basic theoretical concepts of DAX. I keep on telling all my students that learning DAX requires you to understand really well the row context, the filter context, calculate context transition. These are the pillars of the DAX language, and you really need to understand them well. That is why I wanted to create videos for newbies where I introduce the concepts in a simple yet very accurate way. And if you are new to DAX, I suggest you to watch this video once, twice, 3 times until it really becomes boring, meaning that you understood all the details really well. As you are going to see, there is nothing complex, but DAX requires you to be precise. It requires you to understand the details really well. Starting from the next videos, I'm going to introduce more advanced concepts, like the filter context, calculate, and the differences between the different evaluation contexts. That is why you need to start from the beginning, understand it really well, and move to the next step only when the first one is really well understood. With that said, let's start understanding what the row context is. This is the simplest of the evaluation contexts that exist in DAX. You can think about the row context as the current row. Whenever you have a current row, whenever you know where you are during the scanning process of a table, then we say we have a row context. And it is much easier if we start to investigate on what the row context is, looking at some code. So let's go on the computer and let's start learning a bit more. The easiest way to start understanding what the row context is just to create a calculated column. I have my Contoso model here, and if we go to the data view, on sales, I have several columns. I have the order number, the line number, order date, delivery date, customer key, and so on. Using these columns, I can create my reports, but I might want to create further columns. For example, I might want to compute the sales amount. And the sales amount is not available because among the many numbers that I have available, I have the quantity, the unit price, the net price, the unit cost, but I do not have the multiplication of net price by quantity that would produce the sales amount. So what I can do is create a calculated column. That's as simple as going here, creating a new column, and then start writing some DAX code. Let's call this column amount with a much larger font. And amount is just the multiplication of quantity times the net price. If I hit enter, I obtain my result. I immediately format it as a decimal number. And you see that I do have here my new column amount that contains the multiplication of the net price times quantity. With that said, we need to understand a bit better the details. Look at what we are doing here. We are doing the multiplication of the quantity column in the sales table times the value of the net price column in the sales table. Now, in order for this multiplication to have any meaning, in order for the multiplication to produce an actual value, so to multiply, for example, 1 times 116 to produce 116, DAX needs to know which row to consider to do the multiplication, because the value is going to be different for each and every row in the sales table, because we have different values for quantity and for net price. But in the expression I'm writing, there is no specification about which row to consider. I'm just writing the value of sales quantity times the value of net price. How come that DAX knows which row to use? The answer is there is a row context. Because this is a calculated column, the calculated column is being computed row by row. Therefore, the engine knows during each calculation step which row to consider to produce the multiplication. And we have the result that is the value of the amount. We could use this result in a report and be happy. So I can simply take this value, go in my model, in the report, take amount, drop it here, and I have the value. the sum of the amount for each value of for each specific brand. That is because of the filter context, but we will cover the filter context later. For now, let's just focus on the row context. So the first recap, I know it's simple, but it's important, is that you have a row context in a calculated column, meaning that a calculated column is computed row by row, and the engine knows how to which row it is scanning because it is a calculated column. So calculated column, there is a row context by default there. There's nothing you can do to avoid that. Calculated columns always exist in a row context. The row context is not always there. As I said, it is there in a calculated column. But what if I take the same code and write a measure out of it? A measure is different than a calculated column. Calculated columns are computed row by row. Measures, on the other hand, they are computed at the report level. So in a measure, there is no current row by default. And if we want a current row, we need to introduce it. So let's start by looking at what happens if I take the code of the calculated column and I build a measure with the very same code. So I can get rid of this amount in the report. Then I'm going to copy the code of the calculated column. Just copy. I delete the calculated column. And then I want to build a measure, because you might have read maybe on some of our articles that calculated columns, they use space. So it's quite always better to use measures instead of columns. But if I try to do that, look what happens. I cannot write it. I have a red line under quantity, and I do not have a red line under net price, but I should, because both the reference of quantity and net price are wrong. And if you hover, it says cannot find name quantity, even though the quantity column in the sales table is there. If I hit enter, I have the error. And the error is quite cryptic. It says a single value for column quantity in table sales cannot be determined. This can happen when a measure refers to a column that contains many values without specifying an aggregation such as min, max, count, or sum to get a single result. Now, the error is quite cryptic. What the error means actually is that you do not have a row context. Therefore, what is the value of the quantity column? How can DAX transform sales quantity into a value? Is the value going to be 1, 2, 5, 9 or whatever? It's not clear because we do not know which row we are in. And the same is for the net price. If you look at the different rows, we have for the net price a lot of different values. Which one do you want to grab in order to perform the multiplication? It's not clear. The engine does not know in which row it is. That is the reason why in the absence of a row context, you cannot access the value of a column. If you want to access the value of a column, you need a row context that tells DAX which row to consider to grab that value. In a measure, you cannot reference sales quantity because, as I said, sales quantity doesn't have a meaning. Instead, what you can do is perform an aggregation. If I write it as sum of sales quantity times sum of sales net price, you see that the error goes away. I can hit enter and now I have my result. Why that? Because sum of sales quantity is very different than sales quantity. Sales quantity is the value of the quantity column in the sales table for the current row, and without the current row, it doesn't have a value. Sum of sales quantity is a completely different expression. Is the sum of the quantity column in the sales table for all the rows that are visible. It doesn't need a current row because it is aggregating a set of rows. Therefore, it doesn't need one individual value. It aggregates multiple values. The thing is, if I write the expression this way, it's not going to be correct because it's computing the sum of quantity multiplied by the sum of the net price, which is not what I want. I do not want to first aggregate and then do the multiplication. this multiplication needs to be computed row by row for each individual row. Therefore, this expression as a measure doesn't make sense, it just produces the wrong number. If I want to perform an aggregation of a multiplication, what I need to do is scan the sales table and row by row perform a calculation, the multiplication. But in order to do the multiplication, I need the current row, which is not available in a measure. What I can do is introduce the concept of a current row, the row context, using an iterator. So instead of using sum, what I can do is use SumX. SumX is an iterator, so it scans a table. Let me add a bit more space. We can do a SumX over sales of quantity times net price. This expression, written as it is, now works just fine. And in order to understand it well, we need to, again, understand where is the row context and which function created it. SumX is an iterator, so by its nature, it's scan the sales table row by row. It introduces a row context over sales, and then during the scanning of the sales table, it knows which row it is in. It knows it because it is scanning row by row. Therefore, inside that iteration, I can do the multiplication of quantity times net price, because that is an expression that can be computed row by row. And if I format this measure as a decimal number, I can now use it in my report. Where is it? Amount. And that produces the correct number. So I do not need a calculated column to compute quantity times net price. I can create it as a calculated column, just writing quantity times net price. But if I want to compute it as a measure, then I need to introduce an iterator in order to introduce a row context that scans the table. The row context does its job by scanning the table row by row. The row context does not filter a table, and that again is an important concept to understand. Let me show you that with the demo. I can take the same expression that I wrote here, again copy it, and I can create a calculated column out of that. So if I create a calculated column with the same expression, I'm already here. Let's create a new column that this time I call amount column. Amount as a column. Now, before moving further, what number would you expect to see here? Amount call is a calculation. It's an expression that, written as a measure, produces the value of the sales amount, that is the multiplication of quantity times the net price. If I write it in a calculated column, what do I mean by this sales? Is this sales going to be filtered by the current row context or not? Before answering, I want to point out an important thing. We do have here the row context of the calculated column. But here we have the row context introduced by SumX. So when I write quantity times net price, what I actually mean is quantity times net price for which row? Not for the current calculated column, but for the current row that is being iterated by SumX while scanning sales. That is important because that gives you the explanation of why, if I hit enter, you see that the result is not the sales amount for the current row, but it's the grand total of the sales amount. And it is the grand total of the sales amount because the row context does not apply a filter on the model, filtering only the current row. The row context is only scanning a table and providing the current row to an expression. In a measure, you do not have a row context. In a calculated column, you have a row context by default. the row context iterates, it doesn't filter, and that is the reason why if you scan a table or perform calculation in a row context, you have no filter being applied. And that is, again, the reason why we have this amount calculated column that produces the grand total. You can easily fix that and you can easily write different code, but here the goal is not in writing useful formulas. The goal is in understanding the details in a precise way. With that said, this is the row context. There is nothing more to add. But I still want to show you some a bit more intricate code to run through it and understand better how to read the code and what are the different pieces of the row context that are available in different parts. Let me show you that. I have this piece of code that I created just for the purpose of showing some complex DAX code, and I want to run through it with you. The measure is called test, and a bit larger like that. There is the first iterator, SumX. SumX is an iterator, meaning that it introduces a row context, but SumX cannot start until filter starts. So let's focus on this part, filter. Filter, again, is an iterator. It's filtering the customer table, so it's scanning the customer table row by row, and that is the reason why I can write expression like customer country equal USA, because this customer country is the value of the country column in the customer table for the current row being iterated by filter while scanning customer. So we do have a first row context that is introduced by filter over customer. Then when this filter finishes its job, it's time for SumX to start its job of iterating. And SumX creates a row context over the result of this filter. Therefore, SumX iterates a table that contains customers. And SumX starts another iteration. So we have an outer SumX, an inner SumX, and inside we have another filter. So we have 3 iterations happening at the same time. That is 3 different row contexts nested one inside the other. The inner iteration happens on the sales table. Let me clear that a bit. So the inner iteration is over sales. The outer iteration is over the result of filter, meaning that it contains customer. And this is the reason why you can reference sales customer key and customer key. You can access the value of columns in sales and the value of a column in customer, because the 2 iterations are happening at the same time, and you have a current row on customer provided by this SumX iterating over filter, and you have a current row on sales provided by this filter iterating over sales. And the same here, I can access customer age because of the outer iteration happening on the result of filter. Then again, let me clear everything, because the same is happening here. But there is an important difference. When I write sales quantity here and sales customer key here, twice I'm accessing the sales table. But the row context is provided by 2 different functions. This sales customer key, so this one, is produced by filter, whereas this sales quantity is produced by the iteration happening with SumX over the result of filter. So this goes here and this goes here. Reading code like this is not simple. It requires time, it requires exercise, it requires attention to details. This is the first video where we introduce the row context, and as you have seen, there are several details. If I can provide you a hint, just take a look at the code that we analyzed together and perform the same analysis by yourself, understanding which row context is active in each different part of the expression. This exercise is extremely useful to start getting acquainted with the concept of the row context. Then later, next videos, we will start introducing different evaluation contexts. But in order to understand the difference between the row context and the filter context, first you need to understand really well the simplest one, that is the filter context. Whenever you write your code, whenever you look at DAX code, always ask yourself which function is creating the current row, the row context for the expression that I'm writing. With all that said, I hope you enjoy this video and I hope you will enjoy the next ones. If you want to learn a lot more with all the demos and the exercises, we do provide trainings where the topics are covered in an entire way. Here in these short videos, we need to take our topics one by one and then go deeper on each individual one. Enjoy DAX!